Throughout the Gulf of Oman and the Persian Gulf, the morning silence was broken by the roar of Tomahawk missiles fired from American submarines and destroyers. Flying close to the sea, at an altitude of only 9 meters, they followed trajectories calculated with precision the night before, weaving through maritime traffic with a margin of about 1.8 kilometers to avoid visual detection or any risk of collision. At 9:37 a.m., at the Bandar Abbas naval base, the Iranian frigate Sahan remained docked alongside other vessels preparing for the potential closure of the Strait of Hormuz. But before we begin, don't forget to like and subscribe to our channel. What the Iranian sailors didn't know was that the US Navy had already decided to turn every Iranian ship into a sunken target, and it would all begin right there. About 19 kilometers away, the missile paths crisscrossed the Iranian coast, allowing the terrain contouring system to finally find solid references. The radar altimeter picked up the relief of hills and valleys, comparing them to preloaded elevation maps to correct navigation in seconds, like a driver who, after driving in fog, suddenly recognizes a familiar stretch of road. Meanwhile, aboard the Sahan, the NOR defense consoles activated a 4-minute countdown to combat, or 3 if the crew skipped the automatic tests. Destroyer's Combat Information Center Spruance, Officer Tao and his team were monitoring the transmission from an MQ-9 drone on the main display. With only 2 minutes to impact, all they could do was watch the clock. At precisely 9:55 a.m., the impact occurred, momentarily turning the image white. When the video stabilized, black smoke surged across the Sahan Pier, with a secondary explosion engulfing the harbor faster than the morning wind blew eastward. The frigate's launchers didn't even get a chance to fire, and from that moment on, time was running out for the Americans. DISMAC system on the second Tomahawk helicopter, a digital area image correlation system, is comparing the live image from the front camera with a stored satellite photograph of the Sabalon Pier. Think of it as facial recognition, but for structures, it needs to see the same face it has memorized. Clean pier, intact ship, specific geometry. If smoke obscures this image before the missile arrives, DISMAC selects the next best visual match, and the burning wreckage looks more like a ship on the pier than an empty space. A mismatch means the Sabalon remains operational, with its launchers armed and ready to fire. The smoke needs 90 seconds to dissipate. In the MQ-9 transmission, 30 seconds, everything is still black. 45 seconds, the plume of smoke being pulled eastward. 75, thinning out, the bow of the Sabalon emerging like a ghost. At 93 seconds after the first impact, the second Tomahawk crosses the bridge of the Sabalon. The Sabalon survived a bomb weighing approximately 227 kilograms that fell down its funnel in 1988 and was even towed back as a diplomatic gesture. 38 years of borrowed time collected all at once. But 2 frigates are just the beginning. About 4.8 kilometers to the north, a 230-meter ship converted into a drone carrier is already launching aircraft, and the TAO has barely had time to breathe. 3 slow-moving, low-altitude targets, military jargon for drones and small aircraft, have just appeared on the E-2D Hawkeye's radar, departing from Shahid Gary's position at approximately 185 kilometers per hour. A radar signature equivalent to something between a large bird and a trash can lid. The Shahid drones are already airborne. The IRGC's floating drone stockpile, anchored north of the burning frigates, is launching Shahid 136 drones sequentially as their engines allow. 3 have already been launched, and 3 more are ready for launch. Every second that this ship remains operational means another drone flying toward the destroyer, operating about 48 kilometers off the coast. 2 FA-18E Super Hornets of VFA-14 Squadron advance northward, each carrying an AGM-158C LRASM missile under its left wing. Manufactured by Lockheed Martin, The LRASM weighs approximately 1,130 kilograms, flies at just under Mach 0.9, and carries a warhead of approximately 450 kilograms designed to penetrate a ship's hull and explode inside. It can be launched from over 800 kilometers away, equivalent to going from São Paulo to Curitiba, meaning the launching aircraft is already refueling before the target even realizes it's being attacked. But what truly makes it frightening is its autonomy. Unlike the old Harpoon, which requires precise instructions, the LRASM uses passive sensors and artificial intelligence to find and choose its own target. No GPS, no external communication, no assistance. The pilot releases the missile at an altitude of approximately 12,000 meters, and from that moment, the weapon flies alone. A 450-kilogram Predator descending silently, listening to everything and emitting nothing. The pilot is already turning west, because 3 drones Shahed now demands your full attention. Each one carries a warhead weighing about 40 kilograms and flies at approximately 15 meters altitude, below the radar horizon until it is less than 10 kilometers away. The Air Patrol has about 45 seconds to find, stop, and destroy 3 lawnmower-sized targets before they disappear. The first Hornet detects the target with its infrared sensor, essentially a thermal camera that transforms the world into a heat map. At 18 kilometers, a thermal blur appears over the cold water. A Sidewinder missile is launched. The sensor attempts to find heat on a target whose small engine emits less of a thermal signature than a barbecue grill. 3 seconds seem like an eternity. The missile hits and explodes the drone in midair. The second target is destroyed by the 20mm cannon at about 3 kilometers, because the missile needs more heat than that target provides. The third target is also shot down. Meanwhile, about 16 kilometers to the south, the LRASM continues its trajectory without even knowing what happened. Unlike traditional missiles that emit signals and reveal their position, the LRASM remains silent. It listens. It detects emissions from the target itself, radar, radio, navigation, like hunting someone in the dark by the sound of their breathing. So, when the Bagheri moves about 200 meters from its intended position, the missile simply adjusts. For a vessel of 230 meters, this is a negligible error. In the MQ-9 transmission, the Bagheri slowly moves south, still launching drones, while the LRASM covers the last kilometer. The warhead pierces the forward deck and explodes inside the drone hangar. A second LRASM hits the waterline about 30 seconds later. A simply constructed hull facing a warhead of that size doesn't stand a chance. The ship deforms like wet paper, an 11-degree tilt in less than a minute. The Bagheri will never launch anything again, but the 6 drones it managed to get airborne before sinking are now someone else's problem. Bandar Abbas becomes a burning steel graveyard, but some 320 kilometers to the east, another ship is still active and moving into combat. Konarak Naval Base houses the flagship of the Iranian Eastern Fleet, the Jamaran. The ship, showcased for years on state television, is equipped with anti-ship missiles and air defense systems capable of hitting targets up to 20 kilometers away. On paper, it's the pride of the fleet. In practice, it has never seen real combat. Its systems are outdated, and now it faces its first test against the United States Navy. The outcome is uncertain. The approaching pilot already sees the problem on the radar warning receiver. 2 active radars protecting the port, which should be deactivated. The SEED mission, suppression of enemy air defenses, has failed. The anti-aircraft guns are still active. These twin-barreled guns and of Soviet origin fire thousands of projectiles per minute. Anything below 2,400 meters is in the danger zone. He has about 60 seconds to survive because the AGM-84 missile he carries requires manual control in the final phase. In the last 8 kilometers, the camera transmits a live image, and the pilot needs to guide the impact with a control. Remote surgery, but he can't leave until it's finished. Either he goes in now and faces 60 seconds of intense fire, or he waits and gives the enemy time to react. American pilots don't hesitate. He fires. The missile is released, the wings open, and the turbojet propels him south at low altitude. The pilot enters an oval pattern orbit at about 6,700 meters altitude, above the range of the Zu-23 cannons, but still close enough to maintain the data link. His wingman positions himself in a sweeping pattern above him, eyes fixed on the RWR, the radar warning receiver. This system functions as a sixth sense for the pilot, a screen that indicates when enemy radar is illuminating their aircraft and, more importantly, when a missile is about to be launched. At about 8 kilometers from the target, the missile's front camera is activated. The pilot's left display fills with a grainy infrared image. Port, pier, and the Jamaran centered in the frame. Crew members are still running across the forward deck, 3 of them heading towards the NOR stations. If they reach the launchers before the warhead hits the waterline, the situation will quickly become complicated. He adjusts his sights to the stern of the ship, near the engine room, where the hull is thinner and holds. 3 kilometers. 2. He sees the crew approaching the launching rails. 1 kilometer. His sights remain steady. The titanium warhead pierces the hull and detonates inside the engine room. The Jamaran literally breaks apart at the keel, its stern sinking more than a meter in 30 seconds, while water floods in through the ruptured compartments. The Iranian flagship settles on the bottom of its own harbor, while its crew abandons the vessel through hatches that are already submerged. About 320 kilometers to the west, the Jamaran isn't the only sinking vessel. While the missile was being guided in the port of Kanarak, the VFA-41 Black Aces squadron launched 2 GBU-31 JDAM bombs against the Makran ship in Bandar Abbas. The converted tanker that Iran uses functions as a huge floating drone depot. Shahed. Direct impacts on the engine room and aft fuel tank. It's on fire, but it's not sinking, and that's about to become an even bigger problem. The Makran has a 228-meter hull and was built with multiple watertight compartments. A ship that burns without sinking basically becomes a giant torch in the middle of the sea. Its drone stockpiles, located under the forward deck, may still be intact. Worse still, if it breaks free from the pier, it becomes a burning vessel adrift in one of the busiest areas of the Gulf. The formation leader has 2 bombs remaining, a Tor M1 system between him and the target, and perhaps 3 minutes before the moorings snap and the Makran is adrift. 3 countdowns happening simultaneously. The Tor M1, a Russian mobile short-range air defense system, basically a tracked missile launcher, has already locked onto it about 11 kilometers away, just seconds from firing. This particular battery had moved about 800 meters south of its original position during the initial chaos, hiding between 2 warehouses while the first missiles hit empty areas. The wingman doesn't wait for orders, diving from 6,700 meters with a GBU-31 weighing about 900 kilograms, targeting a 37-ton vehicle, like trying to kill a wasp with a refrigerator. But it's the only weapon available at that moment. 30 seconds of freefall against a team that needs only 5 to fire. The Tor M1 team wins the race. A 9-man 3I-31 missile is launched, pulling approximately 30 times the force of gravity. This is enough force to knock out any human being, accelerating directly against the diving fighter. The wingman launches countermeasures and brakes to the right under 7 Gs. The anti-G suit tightens around his legs like a tourniquet. His peripheral vision disappears, leaving only the HUD and the sound of his own breathing. The missile follows the decoys for half a second before reacquiring the target. Half a second at Mach 2.5 represents about 400 meters of deviation. The missile passes so close that it shakes the cockpit. He feels more than he sees. A change in pressure, a shadow, and then nothing. 4 seconds later, his JDAM bomb completely disables the enemy battery. Now the formation leader is already attacking. 2 bombs remaining. He releases the first one at the bow waterline. The hull ruptures beneath the drone compartment. Gulf water floods in from below while fuel surges from above. The second bomb hits the port side amidships, creating a breach that the compartments cannot contain. The Macron sinks by the bow, lists to starboard, and begins the slow process that every sailor immediately recognizes. A ship that has already sunk. A column of smoke kilometers long covers the entire inner harbor. Somewhere below it, 3 ships are still afloat, and all the targeting sensors are now blind. The system shows only a black wall where 3 corvettes should be: Zagros, Byandur, and Nagdi, still armed with anti-ship missiles. Just 40 meters from Byandur are the Kilo-class submarine shelters, 3 vessels capable of closing the Strait of Hormuz if they manage to get out. He has 2 options. The first is to launch the bombs using GPS, like marking a point on a cell phone map. Under ideal conditions, the error is minimal. But the Iranian electronic jamming is distorting the signal, turning a few meters into up to 9 meters of error, enough to miss the target. The second option is to dive beneath the smoke, acquire the target visually, and attack with precision. More effective, but extremely risky. He tilts the nose of the aircraft downwards. A pilot, a bomb, and the entire Iranian coast await him. His wingman positions himself further east, watching the rooftops. A portable missile could appear at any moment. 3 seconds between launch and impact. At 1,500 meters altitude, he first tastes the smoke. It's not a smell, it's a taste. Burnt fuel entering the ventilation system and scraping his throat. The display still shows nothing, just a black wall. 200 meters, still blind. 900 meters. A gust of wind displaces the smoke, revealing the stern of the Byandur. Gray metal, close enough to read the hull number. He moves his sights. The mast of the Zagros appears above a warehouse, another adjustment. The Nagdi is already listing, damaged by shrapnel. 3 ships lined up beside the submarine shelters, and every second down there increases the risk. He takes off. 6 explosions pierce the smoke in sequence, each one opening the hull and allowing water to enter. The submarine shelters are destroyed soon after by other fighter jets. He climbs again to about 3,000 meters and assesses the situation. The eastern pier, where the Revolutionary Guard's fast boats were, is empty. They all disappeared. The port was neutralized, but the boats weren't. 24 fast boats are already in the Strait of Hormuz, scattered among commercial vessels. Each one is equipped with anti-ship missiles with a range of about 35 kilometers. They were designed precisely for that, to blend into civilian traffic and attack. An MH-60 Romeo helicopter locates the first group, 7 boats between a supertanker and a cargo ship. The pilot fires a Hellfire missile, precise enough to destroy the target without hitting the ship alongside. 4 boats are eliminated in about 20 minutes. Many others are still in motion. A P-8 Poseidon enters the scene from high altitude, using radar to track all targets simultaneously. Those in open sea are quickly destroyed, but those that remain close to the tankers are virtually untouchable by larger weapons. 2 FA-18s descend for a cannon attack. The Vulcan fires up to 6,000 rounds per minute. Half a second is enough to completely destroy one of these vessels, but any mistake could affect civilians. By midday, 10 more boats are destroyed or abandoned. More than a dozen manage to reach shallow areas near strategic islands. And there, in tight spaces where radars don't work properly, the situation changes again. But the Navy still has weapons prepared for this. If you enjoyed this video, leave your opinion in the comments. Until next time.